So we're still at step 3, and we want to find the maximum vertical height. So to kind of explain what this is, for those who might not know, here's your rocket. It starts here. We know it goes in a parabolic curve and eventually lands somewhere here. The maximum vertical height is how high it sort of gets at the top of the parabola there, at the turning point of our parabola. So let's look at a bit of information from our previous question. We've got our initial velocity u is 6.9 meters per second, and our time was 1.4 seconds. So what I'm going to start by saying, well, 1.4 seconds is the time it takes to go from when it rockets off and then when it lands. If I take the time and divide it by 2, I get 0.7 seconds, which is the time it takes to go halfway, or the time it takes to reach its peak. So we're going to use this time in our equations, and we're going to use all vertical components, not horizontal components. So really I should be a little careful here, because this 6.9 meters per second is a horizontal component, but the reason I can use that is because the vertical component was the same. Okay, so let's put a little v there, because it's the vertical component of our initial velocity, which is 6.9, and our acceleration is going to be negative 9.8, because we're talking about our up-down movement. Okay, and the reason we're talking about the vertical components is we're trying to figure out the vertical height that it's going up. All right, so let's take our equation s equals ut plus half at squared, and we've got all the information we need. U times time, which is 0.7 seconds, because we're trying to see how long, what height it reaches when it gets to the peak, plus a half times acceleration, negative 9.8, times time squared, 0.7 squared. And you can see when you plug this in, it's going to find the vertical displacement, or the distance from the ground to this height here. So let's go 6.9 times 0.7 plus 0.5 or a half times negative 9.8 times 0.7 squared, and I got 2.429. I'm just going to round it to 2.4 meters if I do it to one decimal place. Therefore, the maximum height the rocket reaches is 2.4 meters. So the maximum height the rocket reaches is 2.4 meters. And I do want to sort of double check if it sounds right, because we always do this. We go, okay, is 2.4 meters a reasonable amount? And a really good way of checking that is to go right to the very, I think, beginning, when we calculate the height of the rocket. So at the very beginning, when we shot the rocket straight up, it went 4.9 meters high, and that sounds pretty reasonable, because when we shoot it on an angle, it shouldn't go as high as 4.9 meters, so it should be something less than that.